Good afternoon. I hope you've all had an appropriate amount of coffee to get you through the afternoon. My name is Jonathan Davis. I'm going to chair the testing and fabrication section of this afternoon. We are now getting to the pointy end of steel reuse and how we embed it into projects. I'm going to be a little bit self-indulgent today and take you through a few context slides, some visual aids to show the issues that we as a steelwork fabricator go through. But I would love to introduce you to the panel. First of all, Roy.
Roy Fishwick, Managing Director of Cleveland Steel. For those of you who haven't heard of us or met us, we've been repurposing, reusing pipe for 50 years, but sections probably only really the last 10.
Hi everyone, I'm Sally Walsh. I'm a Chartered Structural Engineer at WSP. I mainly work on project delivery, so from early concept design all the way through to construction, and the last few years I've been involved in delivering the reuse of steel projects as well.
Hi everyone, Tom Howarth, Senior Engineer here, EMR Reusable Steel. So my background is in structural engineering with some experience on site actually getting steel off the building, and now working with reusable steel from project delivery.
Hello, I'm David Brown. I work for the Steel Construction Institute. I was partly responsible for P427 and largely responsible for P440.
Hi everyone, my name is Michael Sansom. I used to work with David at the SCI, but I now work at the BCSA, which is the British Construction Steelwork Association, where I'm Sustainability Manager. I dug out my first reuse project, which was 25 years ago for British Steel, where we looked at the barriers to reuse. Now I'm not so hands-on, but I do run the BCSA Steel Reuse Working Group that's now over 60 people, whole supply chain, many of you here today. Yeah, I look forward to hearing your questions today.
Okay, we'll share the slides. As we transition to the slides, I would like to say I was fortunate enough to speak at this event last year, and we very much had two projects that we were fairly confident of delivering with reuse on, and since then we've secured a third. I must stress the quantum, which has been a bit of a topic throughout the day today, has varied from 50 tonnes on our first job up to 150 tonnes on our second job, and we're in a fortunate position to be delivering the 70% on the project that Luke Francis took us through before. We're getting to that stage where we're keen and happy to share some of the lessons that we've learned from the practical end, and this is a sort of quite a simple schematic of what a fabrication facility looks like. The purple arrows at the top are automated saw lines. So conventionally, we don't have a guy out with a blowtorch or anything cutting the steel. It is all automated. The steel follows the path of the purple lines onto the drill lines, which is the blue arrows. It goes through a plasma cut for additional fabrication should it need it, and then it goes down one of 3 fabrication bays, and that's when we start to weld stuff to the steel, whether it be new or reused. The first fabrication line with a big red cross in it is our robotic fabrication line, and we are fairly protective of that and not quite ready to put reused steel with existing fittings, etc., that might bugger up the robotic probe and things of that sort of description. I will be sharing covert hand signals with Steve at the back, so I'm not having a fit or anything. This is the text isn't entirely clear, but this is the automated saw line, and I think what's clear from the pictures is that we clamp the section from 4 sides. We clamp the section via the flanges, and we hold it in position via the tips of the flanges. That means that the section gets sawn to accuracy that is always within tolerance, whether it be BSEN 1090 or NSSS. But the key communication there is that we do grab that section from 4 sides. That is going to become very important in some later slides. How do we drill this? How do we cut? We've also got an offline plasma cutter, which is used for things like notches, and it follows a common theme where we're grabbing the section again. So clean flanges, clean outer extremities of the steelwork section are very, very important to us. Then we get to the drilling. Hopefully the video on the right-hand side works, but it involves, again, holding the flanges horizontally and clamping the section vertically. What you can see is a probe that is accurately measuring the location of the web. It locates it as close to the flange as it possibly can, and then we have drill bits that come in from the side and drill to tolerance and the required accuracy. If we had an existing fitting in that area, the probe could clash with it and shatter it, and it would be time to start again. We don't sell tons, by the way. We sell fabrication hours. So every bit of steel that comes out of our shop has an hour associated with it. So it's not a rate per ton. Next slide. This is the robot line, which you can probably see why we don't put reused steel down on it. And I think some of the topics that we will go on to talk about might make us feel more confident if the industry can embrace it accordingly. The robot can't see obstructions, it can just see its end location. So if a probe reaches out to weld a specific location and it hits an existing fitting, then that will slow things down considerably and lead to unwanted costs in rectifying the machine. The good news is, once we get past the saw lines, once we get past the drill lines, and we don't decide to go down the robotic line, we're into conventional fabrication. So welding fittings onto the section and passing it down the lines into treatment. This is a lot more business as usual, and we don't see any sort of limitations into how we manually weld the steel that we put through, whether it be new or reused steel. Focusing on the impact specifically, what we've come here today to talk about. We'll talk about the impacts of the protrusions, the stiffeners in the webs, damage classifications, people have alluded to those a little today, and how we optimise throughput. And I think what's interesting is where we were last year was very technically orientated, and it was about how do we justify reuse steel in as high a damage classification as possible to try and optimise it. I think hopefully my panel will agree with me today that we think maximising throughput is about getting reused steel as aligned to new steel in terms of procurement and production as we possibly can. So some examples of shear studs, some seam welds, etc. The shear studs would be extremely prohibitive, the seam welds less so, but you do get that prohibitive action on the clamping action of the flanges. The two symbols at the top are merely indicating we wouldn't be able to put them down the automated drill line or the automated saw line as currently detailed. That's not to say they can't be fabricated, they very much can, but it would be taken offline and done using manual processes. Next one, Steve. Fittings, potentially a little bit more problematic. The fittings in the corner and the full depth stiffeners are things that can clash with the probe when we come to drill. If I was sat here a year ago, we didn't think anything within the section was going to be a problem. So it's only looking at the jobs that we've done, the fabrication routes that we've had to take, that we've realised that actually cleaning up the inside of the section also yields best throughput on the reused steel. If we can't put steel down automated drill lines, we have to get a person in the fabrication shop to lift that mag drill, which is on the right-hand side of the screen. It weighs about 50 kilograms. So we start to appreciate how much time it is to position, locate, drill one hole, and then move it on. Something that is a very low cost adder in fabrication becomes disproportionately expensive if we can't put this down the automated saw and drill line. Damage classifications. My personal view is I am all for this, but they need to be managed appropriately. The picture on the left is localized dents in the webs, which we're probably not too concerned about. The picture in the middle is where we had a significant defect in the middle of the section, and we could literally rock that steel member on our beds. And the picture on the right is a local flange deformation. None of them unsurmountable, but if it was me, I would be starting to make this steel available for the smaller agricultural type buildings rather than the inner city high-rise buildings that we're dealing with in London. We've been working hard with the entire supply chain, Roy, Tom, and some of these practical details have been born out of the work that we did with Mace and Elliott Wood on JSP. We clearly defined a scope of services for all parties, and we came up with a defabrication scope that was additional to our fabrication costs to minimise the impacts of existing fittings on automated fabrication lines. This, for me, is the utopia and where we all need to get to as an industry. And I think by coming up with standard critical details, we can start talking less about how we embed specific scenarios, and we can be a lot smoother in the transition from the tender period into the delivery period if the things are scoped out appropriately. I think this is the last slide. It was a bit of a whistle-stop tour, so I'm happy to pick up any detail later. I have a feeling I've presented this to you, a few of you before. The conclusion is there's a good way for us to fabricate this, and that's to minimise the impacts on fabrication. We've invested over the years in excess of 20 million on automated fabrication lines, as other fabricators in the room surely have as well. Everything is possible, but we need to keep that project by project review and scope things out appropriately. Final thought from me before we go into the questions is we talked a lot about risk and how we manage that risk. This is still in its infancy. We as a business are 3 projects in, so we haven't created the norms to effectively price the amount of defabrication. Aldermanbury Square was quite light on defabrication. Timber Square, due to the quantum, attracted a little bit more. JSP, 70% of the structure is used, attract more defabrication. So I would combat the myth that reused steel is cheaper or should be cheaper. It takes more engineering, it takes more coordination, and it slows the fabrication down potentially. Am I confident we could get to a status quo on price? Absolutely. And we will continue to build the data as we navigate through the next 12 months. That was context. Hope it didn't start too negative. I think since last year, David, you've published another version of P427 and P440. I wonder if you could just share some of the headline items in there, specifically due to testing, etc.
Yeah, so P427 is on a 2nd edition now. The major changes, well, are relatively minor actually. So there was a bit of clarity on what we were thinking about when we were talking about plastic deformation. There are a couple of additions. So some things we were aware of but weren't originally included, but now people are starting to do things at scale. They now become more possible. So I think Tom later on might mention the sort of testing which is now possible, which is just an opportunity now, which is made possible in the 2nd edition. And there is a brand new section about repurposed steel. So that might have been manufactured to some other standard, or it might have been steel which has been bought for something. Perhaps the project was cancelled. It's excess steel. So how do we deal with that? So P427, I would say, is evolution, not revolution. P440, the feedback is quiet but positive. Not sure how many people are using P440. But interestingly, both of those guides are being picked up in other parts of the world. So in Canada, they were commenting that in the UK, we kind of lead the pack with our ideas about the reuse of steel. And they mentioned both of those guides. So that's something to remember, that here in the UK, we are held up as, well, a good model to follow. So really, there might be something for Tom to pick up later on. There might be something to Roy about repurposed steel later.
I think let's go to Tom now. I think as a fabricator, I'm interested in technical compliance as close to 1090 so that we know that technically we can put a viable solution in. But
Absolutely. So one of the things that we've been working with the SCI through the development of the next version of P427 was looking at how do we test. Testing is an expensive part of the process, and how much confidence is that giving? So there's a bit of a linear relationship. You can test more and have more confidence in the grade, or test less and maybe make some more conservative assumptions. So we've been looking at kind of alternative testing approaches with some research projects with several universities where maybe there's different ways that we can actually get more confidence in the steel. I mean, simply as an example, when you take destructive tests, you take them in a 20-ton batch, and there's a certain cost to that. So when you have 20 tons, it actually works out pretty well. But then if you've only got 1 ton and the testing requirement is still the same, it's 20 times worse in terms of testing costs, which can actually mean that some of the sections, some of the material that could be viable for use is not actually viable for use because you don't have enough of it to scale that kind of testing cost over material. Another point is we touched on 275 and 355. There is some conservative kind of approaches actually built into the testing specimen kind of regime where you may actually downgrade some 355 material because you're not 100% confident that it is 355. But if you can build confidence, you can actually unlock more higher grade steel, which gives more use for that steel.
Fantastic. When we were chatting offline, I think you said that destructive testing might be better than hardness tests and open up a few opportunities.
Yeah, so there's 2 approaches in the guidance at the moment. So hardness testing can correlate with the strength of the steel, but also you want to validate that with destructive tests. So we find that actually in practice, hardness testing, you take a bit more of a conservative approach with that, and additional destructive testing can give you a higher confidence where you can actually increase the grade that you're assuming. There's also some alternative destructive or non-destructive testing methods that may give other ways of assessing the grade, which have been kind of ongoing research projects.
Yeah, great. And David touched on reuse v repurpose, Roy. You expressed opinions last year with your crystal balls. Is there any more clarity on that this year?
Well, yes and no. I mean, in real terms, there is different provenance of material, and we have to be very careful in terms of circular economy that what we're trying to do is prevent waste or prevent the production of new material. So whilst I understand there's a debate about people deciding to take brand new steel and call it reused to demand a premium, because of the fabrication costs at the moment, the way things are priced, that's not a realistic scenario, and there is a lot of waste that arises. So our business for 50 years has been in tubular. Our business model for 50 years has been waste tubulars. Now, a lot of them have never been used because there's a lot of ways that jobs go wrong. And from the experience I've had of the sections and buildings, there's a lot of buildings that go wrong, or at least projects that go wrong as well. So we've acquired 800 tons of a building that never got put up, but it's been fully fabricated. So that material is waste, would otherwise go to scrap. So that's one of the reasons we approached SCI to look at the issue of repurposing in terms of the testing and everything else, because it also casts a different light on the testing. Sometimes you've got much better provenance. If you've got the full traceability of the material, the full document pack and the certificates, how much testing do you really need to do to get confidence? Because what gets forgotten is in the UK, we don't have dozens of steel grades to choose from. You can go in 20 or 30 year blocks where one grade has been the predominant grade for that whole period of time, which is one of the reasons I do bark on about designing with S275 in mind, because if you're designing an S355, technically the building it's come down from has been taken down 40 years too early. So there is the issue that if you can pinpoint the time, and I know Tom and I have both had the issue however with buildings that have been extended or adapted, where you get uncertain then as to the provenance of a particular rafter or a particular column, a lot of times you can get a lot more confidence. So I think we've got to not lose track of the fact that what we want to do is prevent production of new and save the carbon in that manner. And I think ultimately, because provenance is such a key issue, we've got 100% traceability of all our material, we have to answer to that traceability. Then you'll never really do better than that in any circumstance. if people want to put dodgy material, for want of a better word, into the supply chain, they're going to get caught out. But I just never see any evidence of that at all. The industry has been very well managed and very well run for a long time.
Okay, great. Sally, we've talked about P427. Can you give us a practical insight into how useful they are in embedding reuse steel into your designs?
Yeah, I mean, very useful.
You sat there. So,
Yeah, very useful. Ultimately, it's the engineer's responsibility to design and specify the steel, and having the industry guidance allows us to embed that into practice. In terms of design, it's very, very small amount of change, small change to a partial factor, which can be embedded into the standard design procedure anyway. A little bit more complexity when you come across existing openings in sections. But I think to approach this, it's best to sort of step back, take a bit of a pragmatic view. Where is the opening? What part of the section is it in? Do we need to recheck it? Have we already accounted for this in our designs? So all of that is possible with the industry guidance. And I mean, overall, I think over the last year specifically, we've seen a lot more projects over the whole of the UK now, reaching out. I've got Birmingham, Manchester, Cardiff, all looking to do an initial reuse assessment with steel. So I think that we can definitely see the progress we've all made since last year, which is great.
How are you gearing up for future designs in terms of reuse? What nuances have particularly caught you out or resonated for change?
Yeah, I mean, 275's been mentioned. I know we've got sort of two views: to design with it early, to adapt later. My most successful project, actually with reuse, we've gone in after stage 4, so our sections were already designed with 355. I think that the success of this project is actually due to every member of the design team and supply chain all sharing the same goal. That's more powerful than having an original design built with 275. After testing, some of the results came back, 275 steel, and I think John and Laura mentioned it earlier, we went back in and rechecked our design, and actually a lot of the members we'd designed were governed by deflection and vibration, so it didn't have a massive impact, which was great. I do agree though, if that was an extra design check, that if 275 had been incorporated earlier on, we wouldn't have had to do that extra check, go through that extra design step. The other interesting one we've come across recently, which I mentioned to you, was the galvanised steel. Yeah. We thought we'd hit the jackpot when we found loads of 762s ready, perfect match, with designed to really high utilisation, and then we find out they're all galvanised. And that was really where I think as a design team it was important to stay involved in the process, because instead of discounting those sections, we adapted our design. So we worked really closely with Bourne, and we were able to adapt our end connection and also change our shear connectors to shot-fired studs. So we've kept all of the tonnage for those members.
So just to point out for people who don't know, if you try and weld galvanising, you poison your welders.
Yeah. You didn't, yeah.
It's frowned upon.
So that's why we're trying to avoid that.
That's a fantastic success story at a project level, but Tom, I think you take a different holistic view on that, do you?
Yeah, when you have a very motivated project team, as you said, anything is possible, but when you're looking at scaling this to the industry over hundreds and hundreds of tons on large projects, things like galvanised steel can suddenly become not viable. So this is something that we feed back into our sourcing, and we actually can consider that when we're looking at existing building, what proportion is galvanised that actually might be more suitable for a recycling route, versus there's a lot of non-galvanised steel out there, good to go. So that's what we're really focusing on the sourcing. But yes, lessons like that we can really feed back into the whole supply chain.
Sorry, just to say as well, because we've been caught with this, it's not always obvious it's galvanised. When it comes out at the shop, it's nice and bright and shiny and silver. By the time it's gone a lovely mouldy green on site somewhere, it can be a lot more difficult to figure out that's what it is. So it's always worth just taking that check if you don't have the original. It's easy to ascertain, but it's also really easy to assume it isn't when it is.
They sometimes paint over it as well.
As well, yeah.
So you've got to give it a little scratch. And, yeah.
So galvanising aside, Roy, what are the key take-homes for people today in embedding reuse into their jobs from a practical perspective?
I think each process will be different, and I do fully accept that, but it's understanding at what point you're truly ready to go. Because we see a lot of conversations very early that don't develop, and we see conversations that happen late that haven't addressed all the right questions necessarily. So it is the case, to go to your point, of at the moment the market's really only ready to follow the traditional business model, which is the orders get placed down the chain, get to the fabricator goes to order some metal. The fabricator really expects it to turn up looking like new metal, irrespective of the conversations that have gone before, truthfully.
Yeah.
So the nearer to the normal procurement process you can make it at the moment, the less likely you are to have trouble.
And what can fabricators in the room do to make your life easier? We promise we won't be offended. There's some good analogies you gave earlier.
No, sorry, I mean, I forget what I said earlier now, if I'm honest, but...
Well, I think that the point was on a project that's 4,000 tonnes, we might be delivering 150 tonnes into it. You might have 2 tonnes at level 1, 3 tonnes at level 2, etc.
Yeah, and that's completely unanticipated on our part. So I'm very busy promoting a 15% target of reuse. What I hadn't anticipated is that the 150 tonnes out of 2,000 would get called off sometimes 600 millimetres at a time to Surrey, Essex, Hartlepool, Newcastle, Bradford, etc. So there is an economic impact, and ultimately I'm not seeing any projects where the economic impact is ignored, reuse or otherwise. So if you're actually going to deliver, and we've just got it again with a different job today, there's 1 tonne to deliver to Essex. That's a 30-tonne order, but those are the only bits of reuse that they've got programmed into production at this time. It's not a reason not to do it, but it's to understand that either it needs to be costed or the fabricators need to be on board with the fact they're going to have to centralise it and then distribute it with the umpteen vehicle movements that go on otherwise.
I think the galv and the delivery are 2 fantastic examples of how we need to get smarter and sort of improve processes. And it's those tricky little things that often catch you out and are frustratingly annoying. Michael, what are the BCSA doing to support fabricators? I think there's obviously a few in the room today who are embracing it.
Sure.
What's the general view on life?
Well, I mean, you're right. I mean, in the room today, there are 3 or 4 members who are really in the vanguard and leading the way, but we're a broad church and we have some very small outfits that wouldn't know a reused steel beam from a brick, quite frankly. So, you know, it's challenging to get everybody up to speed. I mentioned the working group we have. So when I joined in 2022, BCSA set up a reuse working group, and different from the other BCSA groups which tend to focus on the steelwork contractor, we opened up to the whole supply chain. So I think we need whole supply chain solutions to challenges we're talking about. So the downside of that, the group's almost grown too big. So we're over 60 now. So we're to try and make some more progress on specific initiatives. We're breaking out, actually starting this month, into some specific subgroups. And just to tell you what they are really, they really pick up on the early stuff that Jonathan said. So first one, we're talking about when and what to reuse, and we're going to follow up on the Disrupt 2 findings. Then we're going to do all about how we digitally survey reclaimed steel so we can avoid clashes in fabrication, how we align fabrication with all those tricky automated lines we ultimately want to put our members through, how and when we set and confirm targets on projects, and the 5th one is all about material passporting for reuse and how we can start capturing information today that means we can not have to do all the testing that Tom's talking about. So I think it's an important bit of work there. My personal view is that all the challenges and that we face today, we could have avoided those if we'd done the right things 40, 50 years ago. So even now we need to be thinking more about the future and designing differently and designing for deconstruction and collecting all that information that we now need to get through destructive or non-destructive testing. If we've got all that somewhere in the cloud somewhere, it increases supply. And I'm firmly of the view that we need to get the supply up. Demand and all these guys will take all the supply. So we have to really focus, in my view, focus on the supply side and making sure we're getting more good steel into the market, and then the demand and the design and the fabrication will all follow. So
Thank you.
that's what we're up to.
I'm particularly excited about the digital innovation in this area, because we talk about
Sure,
additional
sure.
fabrication costs and putting steel through specific lines, but if we know where things are, we can do a four-way orientation check and really sell home the point. Before we go into questions, just some closing thoughts. Michael, what's the broader landscape? The BCSA, are they looking at, how's the view on reuse? Is it going to stay as a single lever that complements other design initiatives?
I mean, I think it's difficult to predict. I could use one of Roy's crystal balls to predict the future. I mean, certainly today, I mean, we all know it's a relatively niche thing, and quite how it's going to grow, I honestly don't know. You can envisage a scenario where all buildings are going to have to be reused in this way. We're certainly seeing that in the refurb market. So it's difficult to predict exactly. I'm given all the challenges we face with existing reuse, I think we need to be very careful and choose our jobs wisely. As you know, we're transitioning in the UK to EAF steelmaking, and we're going to need a lot of, we're going to need to keep the quality of our scrap pool up. And one way of doing it is recycling sections like this rather than reusing them. So that's another consideration as well. So it's difficult to predict. It's an important part of, we have our sector roadmap to decarbonise by 2050, and reuse is a central lever in that roadmap. But I think it's difficult to know exactly how it's going to go. It might sort of wither and die. We might decide the better way is to just recycle, or we might mandate all this and we might have to disassemble and reuse everything. So I think watch this space. But we should do more to plan for that future. We can easily, with steel fabrication, all the fabricators record all the test certificates, the welds, who's welded it, the paint. We've got all that information. If we can capture that and future-proof that data set, that's going to make reuse very easy in the future, should we need to do it at scale.
David, what's the next wave of technical literature coming out of the
The next wave really is a significant publication supported by the BCSA, which is just about how you would design a low embodied carbon steel structure. So using reused steel is just one part of that package, isn't it? There's an awful lot about efficient design, clever design, working sections hard, not being overly conservative. So within 2 weeks, ladies and gentlemen, that should be out.
Fantastic. Sally, what confidence do you need from the supply chain, the fabricators, the reuse specialists to continue your confidence in specifications?
I think it is up to fabricators now. I think from a design side, we are quite confident and are able to give reassurances. I've learnt loads over the last year working with you guys on what are the challenges fabricators face. So working with you guys more, being more involved through the process to understand what the limitations are, so that we can then take on board that feedback and try to build it in to specifications to start with would be great. I'm really looking forward to the digital side of things. I've spent a while getting our reuse sections into Revit so we can track changes through design, and going the step further and getting material passports and into Tekla as well. And that side of things, I'm hoping will unlock a lot more doors.
Fantastic. Tom, what do you think we'll be talking about at next year's Circular Steel event? Anything exciting on the horizon?
Well, I'm hoping some big completed projects is at the top of my list. But yeah, I think there's lots of real opportunities of where we're at now in terms of scaling this into an industry standard practice. And some of the challenges that we've overcome, we can then take those into lessons that we apply at scale. So for example, with the fabrication is a really important one. How do we get these onto a robotic line, for example, but also throughout design? We wanted to, get onto a project without any headaches really, but that's maybe a few years.
Roy, anything to add?
No, not really. I think there's projects are happening now, so there will be completed projects. It's heartening that by and large information is getting shared, so we don't all have to walk into the same walls as each other.
Yeah.
And I think the message is so important regardless. So I also don't know what scale this will reach, but it's so empowering to the circular economy generally, and things like refurbishment are so important that all of these disciplines have to be worked out and pushed forward some more.
Great, thank you. Steve, are there some questions to share? Someone might have to read that for me. What key design suggestions would you give to facilitate effective reuse in the future? Sally, are you happy to pick that one up?
Yeah. I mean, we've touched on grade. We've touched on grade. So obviously most of the steel coming out is grade 275. If you can look at your structure and see what's governing the design, is it strength governed, is it serviceability governed, you can make sure that it's more adaptable if your testing results and the steel you end up matching comes out as the lower grade. So that's one thing. But also I would go back to the rest of the team's points, where it's not just about reuse, it's also about specifying different types of low embodied carbon solutions. So I wouldn't pin all your hopes and dreams on reuse, find the most appropriate solution for your project.
Fantastic. I think I would just echo previous panels where we've talked about minimum weight design first pass, and then try and embed reuse into the agenda. I would also add jobs like JSP have been fantastic case studies where they've helped us learn en masse some key fundamentals of how to embed reuse steel, so that jobs like that are going to be iconic. Thinking back, Timber Square, where we were like, right, okay, that's where we figured out how to do it. So, yeah.
I think, Jonathan, another thing, I mean, back when I was at SCI, we did other work there about designing for demountable buildings. They included boltable shear connectors rather than welded ones, and sort of flexible connectors, so you could reuse the same beams with different column sizes. So there are other things you can do, and there's some good SCI guidance on specific design decisions and things you can do to facilitate easier reuse in the future.
One of the things that still blows my mind, not as an engineer, but is how much of the stuff we sell for reuse then gets bloody great holes cut in it. So I've seen rather a lot of photographs of stuff which is emblazoned about the fact it's a reused steel project, where when I look at it, I can see no opportunity for that to be reused again. Now I know we're pushing that a long way down the line, but it sort of undermines the message of what we're saying is we want to reuse everything now, but we're not going to give the opportunity for it to occur later on.
Well, the next set of mined steel that you're going to have to reuse will already have bloody big holes cut in it. So, yeah. How much of the cost of steel when it arrives on site is due to raw material cost? How much is due to fabrication? And how rates? Sorry, my eyes aren't
How does
good.
it change for reuse?
Okay, great. I'll answer that if that's okay. I think it's hard to say. On a typical project, raw material of new steel is about 30% of the cost. Fabrication of that new steel is about 30% of the cost. The rest is made up out of treatment, engineering, construction, delivery, etc. I don't think we know what the impact of reused steel is just yet. As a business, we took a commercial decision to take a step forward on Aldermanbury, where we didn't charge anything, but it was quite a low quantum, and we learned quickly it is. JSP, where it's 70%, we've learned very quickly that the fittings do slow us down. So we do have metrics for that job in isolation of how much the reuse costs. Interestingly, the biggest risk is avoiding existing holes. If we have to start filling existing holes for new incoming connections, that's what is attracting the majority of the cost moving forward. But I think next year we'll have a better feel on the answer to that question. And if I haven't said it already, I think the PCSAs and the early engagement give fabricators like ourselves the confidence to take that step in a trusted supply chain to make some meaningful gains in this area. So I wouldn't underestimate that transition piece that we need as a business. Go on, Roy, you read that. Would the panel...
Oh, hang on, it's moved. Would the panel be open to a collaborative web-based reusable steel database for clients to access, procure from through their design development?
Shall I take that, Roy?
Yeah.
I mean, some of you may know, again, when I was at SCI working a lot in more than I am now in reuse, we developed this prototype database as part of a Innovate UK project and a European funded project pre-Brexit. And it was both. So it was a sort of a database for today, almost like an eBay for reclaimed steel. But again, more importantly, it was a cloud-based system for uploading all information on new steel structures in the UK. So everything that, say, Jonathan Fabricates at Hares, we'd take an IFC model from his as-built structure, it would be uploaded and it would sit there, and we'd collate that in a database with all new steel buildings in the UK, and over time it would grow and grow and grow. When that building came ready to be refurbished or deconstructed, we would know exactly the provenance of every steel beam, connection, weld, paint, coating in that building. And so that is what I did as a research project. We failed to get the funding to commercialize it. The challenge with that is the commercial payback, because we're not, if you put a new building into such a database today, you're not really going to get any commercial payback until that building is deconstructed in 20, 50, 100 years' time. So I'm always open to developing it if somebody's got some good ideas and some cash.
I'll be a bit controversial and say I like talking to people. I like talking to Roy to see what the landscape looks like at any one time, Tom, on what they're up to. I'm not adverse to sending each a material list on a project-by-project basis and dealing with it the traditional way. Here's a material list. What have you got?
From a design point of view, it's not necessarily having visibility of those exact lists. It's just an understanding of what are the typical sections, what are the typical spacings, grid spacings of buildings that are being demolished, demounted. So you can keep that in mind as you're developing your new scheme.
I think it's worth touching on the discussion around what stage to start talking about reuse steel. And there's a few competing views if they come in late and do exact, or come in early and be more flexible. And actually, really, it's a bit of both. I think that links into it. You can engage early, start understanding your requirements, start building in some of these considerations, maybe around 275 or 355, but actually then look at procuring later. So you're not having to exactly know what steel's going into your building until a later stage, but you've set yourself up for success at an earlier stage.
Sorry, just to pick up with that, because I think it's important as well, is that the best analogy I can give, and it would be the thing I'd be most keen for people to take away, is when you're buying reused steel, you're buying a second-hand car. It's a finite supply with an unknown arising. We don't know what we're going to get and when we're going to get it. So this is all about timing. So if you look early but buy late, it probably won't still be there. And this is why I use the second-hand car analogy, because you wouldn't look for a car you want to buy next year, this year, if you're buying second-hand, because you wouldn't expect it would be there when you want it. But you might know you want to buy a second-hand car, and you might know what you're going to look for. So you could detail that spec to then look later. The issue with the database then is timing. And the other issue is how many people are looking at it thinking they're going to gain access to the same stuff, because that's one of the big issues we face currently. If there's one Ford Fiesta on eBay, it's the first man over the line on the bidding on the day that gets it. If you want it in 6 months, it's not there. And I've actually apologised in a few emails recently for sounding like a second-hand car salesman because I'm conscious that's what it sounds like. Do you want this stuff? Well, you better tell me quickly because I've got, my brother-in-law wants it. It's not quite like that, but it is the case. I've got one size in stock at the moment with 4 different projects all looking at the same stuff. And I don't have the confidence to know which one of them is going to actually go forward with a job or place the order. But it sounds really naff when you're trying to say to them, you need to get your finger out or this stuff might not be there.
Okay. I think that's a good natural end to it. The questions have disappeared anyway, so grab me if you want to chat about anything else later. Thank you.
Cheers.